Here is a matching type question. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us begin solving this step by step. The key principle governing nucleophilic carbonyl addition reactivity is electrophilicity of the carbonyl carbon. Greater positive character on the carbonyl carbon from electron withdrawing inductive resonance effects or reduced steric hindrance increases reactivity toward nucleophilic addition. Set 1A versus B. In A, ClCH2 adjacent BrCH2C is equal to O CH3. The electronegative Br is on the alpha carbon directly adjacent to C is equal to O, withdrawing electron density inductively more effectively than in B where Br is on the beta carbon, 2 carbons away. Greater inductive withdrawal in A makes the carbonyl carbon more electrophilic. Answer A. Set 2A versus B. In A, diacetyl CH3, CH3, 2 carbonyl groups are adjacent. Each carbonyl withdraws electrons from the other, making both more electrophilic. In B, butanone, there is only one carbonyl with an alkyl group donating electrons. The mutual electron withdrawal in A increases reactivity. Answer A. Set 3A versus B. In A, p-methoxybenzaldehyde, the OCH3 group is electron donating by resonance into the ring and further into the aldehyde carbonyl, decreasing electrophilicity. In B, p-nitrobenzaldehyde, the NO2 group is strongly electron withdrawing by resonance, increasing the electrophilicity of the aldehyde carbonyl carbon. Answer B. Set 4 versus B. In A, p-tolualdehyde, ArCHO, the aromatic ring delocalizes electron density onto the carbonyl by resonance, reducing electrophilicity, and the paramethyl group is electron donating. In B, acetaldehyde, CH3CHO, the methyl group is a weaker donor than an aryl group, and there is no resonance delocalization reducing carbonyl electrophilicity. Acetaldehyde is also less sterically hindered. Answer B. Set 5A versus B. Cyclopropanone, 3-membered ring, is much more reactive than cyclopentanone, 5-membered ring, toward nucleophilic addition. The small ring angle strain in cyclopropanone means the carbonyl carbon is forced to adopt geometry closer to sp3 in the transition state, which relieves ring strain. The ring goes from ~60° bond angles toward the tetrahedral ~109°. This strain relief accelerates addition. Cyclopentanone has near-ideal ring geometry and no such driving force. Answer A. Set 6A versus B. In A, the CHO group is on the aromatic ring at a position where the nitrogen lone pair from the NH of the tetrahydroxyquinoline can donate electron density through the aromatic ring to the aldehyde via resonance, reducing its electrophilicity. In B, the CHO is positioned such that it is less influenced by nitrogen donation. Different positional relationship in the tetrahydroquinoline framework makes an lone pair donation to the CHO position less effective through resonance, leaving the carbonyl more electrophilic. Answer B. Set 7A versus B. In B, the aldehyde carbonyl at C1 of the chromanone isochroman system is flanked by the lactone ester carbonyl, providing an additional electron withdrawing group directly adjacent or in conjugation, further activating the CHO toward nucleophilic attack. In A, the CHO is at C4 of the chroman ring, less influenced by the lactone. The additional electron withdrawal in B makes it more reactive. Answer B. Set 8A versus B. In B, the CHO-bearing carbon also carries a Cl substituent, an electronegative halogen directly on the same carbon as CHO, making it an alpha-chloraldehyde. The inductive electron withdrawal of Cl directly on the same carbon as the aldehyde significantly increases the electrophilicity of the carbonyl carbon. In A, the ChO is on a plain CH carbon with no such activating group. Answer B. Set 9 A versus B. In A, acetophenone, pH, CH3. One side is a phenyl group, electron withdrawing by induction but donating by resonance, and one side is methyl. In B, benzophenone, pH, both sides are phenyl groups providing more resonance delocalization of the carbonyl, reducing electrophilicity, and also providing greater steric hindrance from two aryl rings. Acetophenone has less steric crowding and the methyl group donates less electron density by resonance than a second aryl group. Therefore, acetophenone is more reactive. Answer A. Set 10 A versus B. In A, butanone, CH3, CH to CH3, it is a dialkyl ketone. In B, benzaldehyde, PHCO, despite the aryl group's resonance donation reducing carbonyl electrophilicity compared to aliphatic aldehydes, aldehydes are generally more reactive than ketones toward nucleophilic addition because 1. Aldehydes have one H, not an alkyl group, on the carbonyl, so less steric hindrance, and 2. Alkyl groups are more electron donating than H, making the ketone carbonyl less electrophilic. Benzaldehyde, even with aromatic resonance delocalization, is still an aldehyde and more reactive than butanone, a ketone. Answer B. Therefore, the correct answer is set 1A, set 2A, set 3B, set 4B, set 5A, set 6B, set 7B, set 8B, set 9A, set 10B. Therefore, the correct matching is set 1 matches A, set 10 matches B, set 2 matches A, set 3 matches B, set 4 matches B, set 5 matches A, set 6 matches B, set 7 matches B, set 8 matches B, set 9 matches A.